Next, we're going to look at spectral output. So this chart here shows you the spectral output of both a lamp system here, very broadband, goes from about 250 to 500 nanometers, versus an LED spectral output here. In this case, our 365 nanometer output. So it's clear it's a very broad lamp-based versus a narrow spectrum of an LED. The LED is typically about 10, 15 nanometers. But which is better is the question. And the answer is really each has an advantage in different areas. If we look at the actual curing requirements, in order to cure adhesive, the adhesive must receive sufficient light of the correct wavelength in order to start the photoinitiator reaction, in order to cure the adhesive. So when you look at the narrow spectral band of the LED, you realize that it's now critical that you match that spectral output of the LED with the absorption spectra of the photoinitiator within your adhesive. If you don't match those two up, you're not going to get any curing, regardless of the irradiance level. That's one of the reasons with our LED system we offer 3 different wavelengths. It makes it a little bit easier to match the wavelength of the LED to the requirements of the adhesive. However, when you compare that to the broadband of the lamp, you can see that it's much easier for a lamp system to be compatible with the adhesive that you're using because it's going to cover the entire spectrum of the photoinitiator. However, the other aspect of the spectral content is heat. So light beyond that is needed for the photoinitiator is now absorbed by the adhesive, and that generates heat. You also get light that's absorbed by the materials that are being joined, and again, that's going to generate heat. So although with lamp-based systems you can use filters to reduce the spectral content, what you're going to find is that with an LED system and the narrow band of an LED, you're going to get much lower heat. The chart here gives an example of a process where we actually measure the temperature using various curing technologies. So the blue line here is 2 parts joined together with a lamp-based system with no filter. And you can see it reached a maximum of about 53 degrees Celsius. We threw in a 320 to 500 nanometer filter, reduced the spectral content, and we were able to reduce the heat down to 40 degrees. So it's a pretty significant reduction. But down here, when you use an LED system, in this case a 365 nanometer LED system, you're able to reduce the heat down to about 3.5 degrees Celsius. So much better management of the heat with using LED. So a big advantage to LED. Now, again, with our system, we have 3 different wavelengths to choose, 365, 385, and 400 nanometers. So which one is best for your process? Many adhesives will specify 365 nanometer light, and that's traditionally they've been designed to match up with 365 nanometer peak of mercury lamps. What we find in our testing though is many free radical formulations will cure quite well with wavelengths up to 420 nanometers. Cationics, they tend to cut off a bit lower, up to about 380 nanometers can cure them quite well. And in general, using a 400 nanometer will actually give you a better through cure than a 365, whereas a 365 nanometer LED tends to give you a bit better surface cure than the 400 nanometer. And finally, you can't forget the substrate that you're joining as part of your decision-making process on which wavelength is best suited. This here, it gives an example of some testing that we did, joining 2 plastic parts, using adhesive where it specified 365 nanometer wavelength to cure the adhesive. But when we actually went and tested the transmission of light through the plastics, we found that at 365 nanometers, the parts being cured were actually absorbing about 50% of the 365 nanometer energy. So only half the energy was actually getting to the adhesive. Whereas at 400 nanometers, you're now getting about 80% transmission of the light. So you're getting much higher energy through the parts to the adhesive at 400 nanometers. And what we actually found is that at 400 nanometers, the adhesive cured faster and with less heat as compared to the 365. So in this case, if you had followed the specs of the adhesive exactly, you probably wouldn't have had the most efficient process for assembly. The other thing to look at with adhesive compatibility, and again, this is a really important point that we get asked all the time, is many adhesives have been designed to work with broad spectrum of lamp-based systems. Many of them will have multiple photoinitiators, varied absorption peaks, and again, that was to take advantage of the broad spectrum of the lamp systems. So if you now want to move your process from a broad spectrum of a lamp to the very narrow spectrum of the LED, will you get the same curing? And it's a really important question to ask, because if you don't get the same curing, then obviously you need to know that as part of your testing. So I wanted to share with you some of the testing that we've done along those lines to really try and identify whether taking a process that you know works with a lamp system, transitioning it to an LED, and see whether or not you're going to get the same results. So the chart here shows results of what we measured here, and in this case it's micro hardness. Now we use micro hardness as an indicator on whether or not an adhesive is cured. It's not an exact confirmation that the adhesive is fully cured. But what you do is if you cure an adhesive to the point where you know it's cured, you measure the micro hardness. This now gives you a baseline. So as you're doing further testing, you know that if you reach that same micro hardness, it's at least an indicator that your adhesive is fully cured. So in this case, we took an adhesive that we knew if we cured it with the lamp, we would get it fully cured, and we reached a micro hardness of right around 60. Took the same adhesive, replaced our lamp with an LED system, in this case, a 365 nanometer LED system, and we achieved a micro hardness even a little bit better. So based on this, it would at least indicate that the LED system did cure the adhesive at least equally as well as the lamp system. However, when we took those same samples and did really a more direct analytical testing with them, in this case we looked at them, we've got it at a DSC system, where we could actually show the amount of uncured material within those samples. What we found is this line here, the blue line, shows the sample that was cured by the lamp-based system versus the red line, which was the sample cured by the LED. So, in fact, although both samples achieved the same micro hardness level, there was significantly more uncured material within the adhesive that was cured by the LED. So based on this further testing, you would have to say that no, these adhesives were not cured equally well with both lamp and LED. Now this is just one example of one adhesive, but I think it's really important to make this distinction that curing with an LED is very different than curing with a lamp-based system. So it's very important that you follow through on the testing, on the analysis, to ensure that you are getting the same cured properties with either of the technologies. So finally, we'll talk a little bit about radiometry. Again, lamp systems have been around for years. The radiometry is very well established. There's a number of radiometers out there that work very well for measuring the output from your lamp-based systems. So although LEDs we saw degrade much slower than lamp-based systems, they do still degrade. It's still very important that you're monitoring and measuring the output from your system. The challenge with LEDs is that unlike the lamps, one, they're a very narrow spectrum, but two, it's also very narrow beam patterns, and both of these present challenges for radiometers. So we've actually introduced the new Omnicure LED light meter, which we think has really tackled both of these challenges in a very unique product. What we've done is we have a very special calibration process where we actually calibrate the sensor at 10 nanometer intervals from 300 nanometers up to 720 nanometers. What this allows you to do is you can actually now select the specific wavelength that you're using to match up with your LED system and measure the output at that specific wavelength, knowing that your radiometer has been calibrated traceable to NIST at that wavelength. So we think it's a pretty unique product that, again, will be very helpful for medical device manufacturers who need radiometry to measure and maintain the output for their system. So if we go back and really summarize the different features that we looked at in the lamps and the LED systems, and we compare which one has the advantages, what we see is the LED certainly has advantages in things like lifetime, environmental, the electrical power requirements, again, advantage to LED. But things like the picoradians, spot size, lamp still has a definite advantage there. As far as the spectrum goes, you have the broad spectrum of the lamp versus the narrow of the LED, and each one has their own advantages. Certainly LED has the advantage of lower heat, where the lamp system really has the advantage of better compatibility with adhesives. Although I must say that more and more adhesives are being designed specifically to work with LED curing systems, and so there's a different set of photoinitiators being used, a different chemistry, And so as we move ahead, there's definitely going to be much better compatibility of the adhesives with the LED systems as they go. The formulas are getting better working with the LED systems. And then finally, radiometry in the lamp system is much better established versus the LED, where it's really still being developed and perfected. So based on this, which system is best for you? And well, the answer to that is, unfortunately, the answer to that really is going to depend upon your process, the parts you're joining, your application, and really what works for you. I think the key, though, is to really understand the different benefits that each one brings and really help you to use the best technology for your process. And for that, we'd be happy to work with you and help you out, because we do have both technologies available. So by all means, come visit us at booth 2227.